Hi guys, today we're going to cover section 8.2, series and sequences. This is just a very basic introduction. So in the next two sections, 8.3 and 8.4, we'll focus on some of the specifics. But this is just very general introduction. Okay. So if you look under things to know, we're dealing with essentially two types of sequence. You have the infinite and finite. So infinite and finite, just like the name sounds. Infinite means it just keeps going, and finite means there's a certain number of terms. Okay. And the part B, when it says how the function and sequences are related to each other, so a really quick example would be something like this. Say, for example, we have y equal 2x plus 1, and here I can make a table. 1, 2, 3, 4. Right, and if I complete the table, I would have when you plug in 1, you get 3, then you get 5, then you get 7, and you get 9. Okay, so this is what a function and a table would look like. Now, what I could do is I can take these values from the table and write it as a sequence. So the sequence, the first term will be 3, and the second term will be 5, and third term will be 7, it will be 9, and so on. Okay. So this is how the series and the sequences and the functions are related, right? We can take a set of numbers from table, and then we can go ahead and just lay them out in order. So that's one way. We'll spend a little bit more time on the different type of sequences later, but for now, this is a good representation on how they're related. Okay, and we'll look at series later. Series just means that instead of listing out the numbers, you're now adding them. Okay. All right. Okay, so let's go ahead and look. We'll talk about the rest of the things to know as we go, but let's go ahead and start looking at some of the examples. All right. So now we're supposed to find the next term of the sequence. So you have 2, -6, 18, -54, and try to figure out what the next number is. So when you're looking for a sequence, there is always a pattern. We just got to figure out what the pattern is. And hopefully, by looking at this, you should see the pattern is multiplied by -3. Right? To get the next number, we always multiply by -3. Right? Always multiply by -3. Multiply by -3. So which means the next number will be -54 times -3, which is 162. So our next number will be 162. Okay. As far as for part B, you have the -1, 7, 15, 23, the dot. And in this case, hopefully you recognize it. We're adding 8 each time. So which means to get the next number, we'll have to do 23 plus 8. So the next number is going to be 31. Okay. So in this case, right, what we're trying to do is we're looking for a pattern. Right? We're looking for a pattern from the existing sequence. But there are times where they're going to actually give you the formula. So if you look at number 3. Number 3, you have the notation a sub n equal n over n plus 1. Okay, so the a sub n means nth term. Alright, now, so if you're looking for the first term, that means my n will have to be 1. So first term would be a sub 1 equal 1 over 1 plus 1, which is 1/2. Okay. A sub 2, same idea, plug it in. 2 over 2 plus 1, which is 2 over 3. A sub 3, 3 over 3 plus 1, which is 3 over 4. A sub 4, 4 over 4 plus 1, which is 4/5. And A sub 5, 5 over 5 plus 1, which is 5/6. Okay, so this is how you figure out the terms. So the next one, we want 18, A sub 18. So that'll be 18 over 18 plus 1, which is 18 over 19. Okay, the goal is for you to know how to find the terms when you're given a formula. Okay. Now for part B, the formula we have for nth term is n factorial. Okay, so in case you have never seen factorial, factorial means, so n factorial means n times n minus 1 times n minus 2, so on, times 3 times 2 times 1. Okay, n is an integer. Excuse me, not integer. N is a whole number. Okay, n is a whole number, and so, for example, if this was 1 factorial, this just means 1 times. This means 1 by itself. If you do a sub 2, which is 2 factorial, this means 2 times the number that's 1 down until you hit 1. So which is 2. A sub 3. 3 factorial means starting at 3, then you multiply by the next whole number down, multiply by next whole number down until we reach 1. So this is 6. A4. A sub 4. 4 factorial. So that's 4 times 3 times 2 times 1. Stop at 1. So this is 24. And a to the 5th. 5 factorial. That is 5 times 4 times 3 times 2 times 1, which is 120. So if you keep going, a sub 8, that's going to be 8 factorial, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And the calculator does have a factorial button. So if you go to typing number 8, hit math, scroll over to probability, and you'll see the exclamation mark there. And that will give you 40320. Okay, the factorial are being used in statistics. They're using statistics a lot in discrete mathematics. So it's good to know. Now, if you're taking a stats class, you'll definitely need to learn how to use factorial, because of the binomial and the combination and the permutation. Those are things that you're gonna encounter in the stats class. So like at GRCC, the math 215 that's something that you will definitely see that in there. Okay, all right, let's move on to the next set. Now, problem set number 4, it says write the first 4 terms of the recursive sequence. Okay, recursive sequence is the type of sequence that relies on previous values. Okay, what I mean by rely on the previous value is, in order to figure out a specific term, you need to know the value of the previous. Now, in problem set number 3, where we can just plug in the formula, those are not recursive, because I can just plug in a number and figure out the specific term. Okay, So that's the reason why for this problem, notice I've listed out the first term being 3, and a sub n is 2an minus 1 plus 5. Excuse me. So right now, if I want to find out a sub 2 is, notice where the n is, right? I replaced the n with the 2. So this is 2 times a to the a sub 2 minus 1 plus 5, which is 2 times this right here is now a sub 1 plus 5. And what do we know about a sub 1? It's 3. So a sub 2 is 2 times 3 plus 5, which is 6 plus 5, and that is 11. So a sub 2 is 11. A sub 3. Well, what is a sub 3? Same formula. A sub 3 is 2 times a sub 3 minus 1 plus 5, which means 2 times a sub 2 plus 5. And what do you know about a sub 2? That's 11. So 2 times 11 plus 5 is 27. Okay? A sub 3 is 27. A sub 4. 2 times a sub 4 minus 1 plus 3 plus 5. So 2 times a sub 3 plus 5. So 2 times 27 plus 5, which is 54 plus 5, that is 59. Okay. So notice, right, to figure out a term, I have to know the previous. Okay, you have to know the previous term. So this is what's called a recursive sequence. You have to rely on the previous term. Rely on knowing the previous term. Okay? Alright, so part B. Part B, here we go. We have x1 equal to 2, x2 equal to 3, and x sub n is 2xn minus 1 plus xn minus 2. Okay, so this recursive sequence actually requires you to know 2 terms instead of 1 term like the previous. So let's go ahead and start out with x plus x, the third term. So the third term means I need to take 2 times x sub 3 minus 1 plus x sub 3 minus 2, which means this is 2 times x sub 2 plus x sub 1. X sub 2 is 3, so 2 times 3 plus x sub 1, which is 2. So the answer is 2 times 3 is 6 plus 2 is 8. A little bit awkward, right? Because now we got 2 terms we got to worry about. So x sub 4. X sub 4 means 2 times x sub 4 minus 1 plus x sub 4 minus 2, which means 2 times x sub 3 plus x sub 2. We know x sub 3 is 8, so 2 times 8 plus x sub 2, which we know is 3. So this is 16 plus 3, which is 19. Okay, a little bit different. It's just slightly different. All right, so that should be good. That should be good enough for sequences, right? So again, this is just a brief introduction about sequence and how to find terms. So we'll focus on some specifics in the next few sections. But now let's go ahead and figure out series. Okay, remember series means what? We add all the terms together. Right? So series, you're going to get a numerical value out of it. And the notation is this. We use the summation notation. The summation notation is the sigma. And the number on the bottom tells you where to start. The number on top tells you where to end. So this problem is telling me I need to start on the first term and end on the fourth term. And the 3i minus phi in this case is our formula. Okay, so there are several ways to do this problem, and I'll show you a couple ways. So in this case, let's go ahead and do it. Let's go ahead and just write out all the terms. So first term is going to be 3 times 1 minus 5 plus second term 3 times 2 minus 5. And we're going to keep going. 3 times 3 plus minus 5, sorry. Plus the fourth term. 3 times 4 minus 5. So our final answer is going to be 3 minus 5, that is a negative 2, plus 3 times 2 is 6, 6 minus 5 is 1, plus 3 times 3 is 9, 9 minus 5 is 4, plus 3 times 4 is 12, 12 minus 5 is 7. So final answer is going to be, let's see, 7 plus 4 plus 1 is 12, so the answer will be 10. So the answer for this is 10. Okay? Alright, I'm going to bring this to a new page because I'll show you what the other way we can use to figure out this particular series. So if you look at the in a section, there are some properties for series and sequences. Okay, so here you go. On page 782, it says, so if I have if I'm adding a constant together, so if k equal to 1, so it's starting at 1, the first term, ends at the nth term, and this is a constant. The answer is just c times n. Okay? And we'll apply these formulas. And if you have the summation, again, starting at 1, ends at n, and you have a constant multiplied by a function, what it does is that you can take that c, put it in the front, so you can evaluate the function first, then multiply everything by c. Okay? And the last formula is if you have a summation starting at 1 and ends at n of two functions adding or subtracting, you can split them. So you can write it as two separate summation notations. Okay. So how's this gonna help us with our problem? Well, let's take the problem we just did for example. Let's work on it. So again, we have the summation from I from 1 to 4, and our formula is 3i minus 5. So notice 3i minus 5 is technically two separate functions, so I can split them. I'm going to split them into two. Okay. Now notice the 3i, right? The 3 looks like this rule right here. So which means I gotta put that 3 in the front. And minus summation notation I equal to 1 and 4 from 1 to 4, and the formula is 5. This looks much like the first that we have, right? So if you think about it, this right here is literally 5 times 4, right? Because it's just the constant multiplied by the n on the top. So this is literally 5 times 4. Okay? Whereas the first summation is 3 times 1 plus 2 plus 3 plus 4. And if you think about it, 1 plus 2 plus 3 plus 4, that is 10. So essentially what I have is 3 times 10 minus 20. So 30 minus 20, which is 10. Okay, which is that's the same answer as we have. All right. Now the reason why we're using a formula here is that sometimes the numbers are so huge, it's kind of hard to do. Whereas the formula property base will make things a little easier instead of writing everything out. So do it at your discretion, okay? Or do it the way I ask you to do. All right, part B. Sigma I equal to 1. This is 5. And you have a constant right here. Again, that is a constant. So that goes with the formula. Right, that's for the constant formula. So this is just 2 times 5, which is 10. All right, for the part C, the sigma I equals 3. Be careful, I equal to 3, not 1 anymore. And this is 6. And this is going to be 2i minus 1 squared. Okay, so if I were you, we can. There's a couple of tricks that we can use here to figure this one out when the I is not equal to 1. But I think just with the small number that we have, I'm just gonna go ahead and plug it in, and we're gonna plug it in and figure out what it is, the longer way. So, or the regular way, I guess. So here we go. So this is 2 times 3 minus 1 quantity squared plus 2 times 4 minus 1 quantity squared, and plus 2 times 2 times 5 minus 1 quantity squared, and plus 2 times 6 minus 1 quantity squared. So 2 times 3 is 6, minus 1 is 5, 5 squared is 25. 2 times 4 is 8, 8 minus 1 is 7, 7 squared is 49. 2 times 5 is 10, 10 minus 1 is 9, 9 squared is 81. And last term, 2 times 6 is 12, 12 minus 1 is 11, 11 squared is 121. So essentially this is 25 plus 49 plus 81 plus 121, which is 276. Okay. Now there are some tricks that we can use for square terms, and that one is not included in this textbook, so I'm not going to introduce it. But this way will take care of majority of things. Okay. All right. Sounds good. And this is it for 8.2. It's quick and painless. Any questions? Please let me know. And you know how to get hold of me. All right. Talk to you guys later.